Okay, so in this video we are going to calculate the mass of the star Proxima Centauri. And we're going to be basing this on information that has been recently discovered regarding an exoplanet that is orbiting that small star. Now that star is part of a triple star system. It's kind of interesting. There is Alpha Centauri A and Alpha Centauri-b. Those two stars are orbiting a point that's called the barycenter, which is the center of mass between those two stars. So those two stars are orbiting this barycenter in some complicated way. And then way outside of that, there is a third star, which is called Proxima Centauri. And it has an exoplanet that is orbiting it, and that's called B, lowercase b. So this is the Alpha Centauri, Proxima Centauri system. Proxima Centauri is called Proxima because it is the star that is closest to Earth right now, closest to our sun. So that star is about 4.24 light years away from us, which is an incredible distance. Well, anyway, what we're going to do is we're going to calculate the mass of that star using the orbital information of its exoplanet. We're also going to use the Kepler's third law, but it's manipulated into this form. So we're going to do some calculator activity here. Okay, so the first thing, right, is let's figure out what is in these parentheses. This is 4 and then pi squared. So we're going to get pi and then square it. And so we see that that is 9.8696. And then we're going to divide by capital G, which is 6.67 times 10 to the negative 11th. So we have that so far. Now, up here I've also given you information that the orbital radius of this exoplanet is 7.5 times 10 to the 9th meters. So we're going to make this fraction outside where we have 7.5 times 10 to the 9th, and we're going to cube that. And then in the denominator we have the period, the orbital period of the exoplanet, which is 967,680 seconds, and we're going to square that. Okay, so we need to do the arithmetic here. Okay, so as you recall, on the screen here we have pi squared. We're going to multiply that by 4, and then we're going to divide that by 6.67 times 10 to the negative 11. And so for that we get 5.9188 times 10 to the 11th power. And we still have this fraction out here to evaluate. 7.5 times 10 to the 9th cubed over 967,680 squared. So now let's deal with that. So we have 5.9188 times 10 to the 11th. And let's do 7.5 times 10 to the 9th power. And then we're going to cube that. So we use this y to the x key and then put the third power, and we get this. 4.21875 times 10 to the 29th power. Okay, and then in the denominator we had 967,680, and we're going to square that, which gives us 9.3640 times 10 to the 11th power. Okay, so the next thing is let's divide the fraction here. So we have 5.9188 times 10 to the 11th power. And now we're going to do 4.21875 times 10 to the 29th power. And we're going to divide that by 9.3640 times 10 to the 11th power. And we get this, 4.505286 times 10 to the 17th power. Now, since we have that on the calculator already, and we need to multiply by this number in front here, 5.9188 times 10 to the 11th, let's just multiply by 5.9188 exp 11. And we end up with, let's round this off to 4 digits after the decimal point, 2.6666 times 10 to the 29th power, and that is kilograms. So that is, given the orbital radius and orbital period of the Proxima Centauri lowercase b exoplanet, that seems to be the mass of Proxima Centauri. Okay, and now if you recall, the mass of the Sun was 1.989 times 10 to the 30th kilograms. Okay, so if we divide this number by the mass of the Sun, 1.989 exponent 30, okay, that means that Proxima Centauri is only about 13.4% the mass of the Sun, of our Sun. Proxima Centauri is said to be a brown dwarf, and now we can see why, because the mass of that star is considerably less than the mass of our Sun.